Okay, so we're going to look at some linear rates of change. And remember, we've talked about this so many ways. Linear rates of change we've called constant rate of change, slope, delta y over delta x. We use the letter m. It's y2 minus y1 over x2 minus x1. So many ways to talk about that. If we're looking at a table, we can take any two points from that table and use the formula m equals y2 minus y1 over x2 minus x1. So if I decided to, say, take these two, I might say 11 minus negative 1 in the numerator, but then the denominator has to be in the same order. So I can't put 0 minus 3 in the denominator. Since I started with the 11, I have to start with its partner, so 3 minus 0. Well, 11 minus negative 1 is 12. 3 minus 0 is 3. So my rate of change here is 4. Now, that is not the only way to do this. We also, and it's really the same thing, but we've talked about this in the form of delta y over delta x. So let me refresh your memory what we mean by that. The delta y is the change in y. So if I just looked at these and said, okay, from negative 13 up to negative 5 goes up 8. Negative 5 up to negative 1 is up 4. And then negative 1 to 11 is up 12. Now, none of those seem to be a constant pattern, but that's because we don't have a constant rate of change or constant change in the x column either. But let's compare negative 3 to negative 1 goes up 2. Negative 1 to 0 goes up 1. And 0 to 3 goes up 3. So what we mean by the delta y over delta x is as long as that ratio is always the same, 8 over 2, because 8 and 2, 4 over 1, 12 over 3, those fractions are all equivalent. So you could take any one of those and just simplify it. Here's one that's already 4 over 1 is equal to 4. Okay, so if I decide to use that delta y over delta x method in number 2, I would look and go, okay, this goes up 8, then here it only goes up 4, then here it goes up 8 again. But by comparison, the x values go up 4, then 2, then 4 again. So my delta y over delta x could be 8 over 4, or 4 over 2, or 8 over 4, any of those. You don't need all of them. And what each of those would simplify to is just the number 2. So my rate of change is 2. And one more like this. In number 3, if we go up 6, up 8, up 10, but compare that to up 15, up 20, up 25. If we make ratios here of the change in y over the change in x, 6 over 15, 8 over 20, 10 over 25, each one of those can be simplified. If you divide 6 and 15 both by 3, that's 2/5. 8 and 20 can be divided by 4, so that's 2/5. 10 and 25 can both be divided by 5, so there's 2/5. So these are equal, and my rate of change is 2/5. All right, and we're going to do a few graphs using slope-intercept form. Slope-intercept form, if you don't remember, is y equals mx plus b, where our m is the slope, the rate of change, the delta y over delta x, and the b is the y-intercept, or the 0th term. So when we're lucky enough to get an equation in that form, I know here that negative 1 is the y-intercept, so I can go ahead and put that on the graph. And then the slope is 3, and slope, another way I didn't even mention that we talked about slope, is rise over run. So if we want our rise over run to equal 3, making that a fraction, that'd be 3 over 1. So from that starting point, that y-intercept, we would just rise 3, 1, 2, 3, and run 1. Now 2 points is enough to make a line. Depending on how neat you are, though, you might want to go another. Rise 3 more, run another 1. Rise 3 more, run another 1. Could also go in reverse. Down 3, left 1. Then take your straight edge and make your line. Number 5. Now our y-intercept is 4. So y-intercept, is positive 4. The slope is negative 5. So if our rise over run is negative 5, again, we want to think of it as a fraction, so that's over 1. From our y-intercept, we can go down 5, 1, 2, 3, 4, and 5, left 1. Let's do it one more time. 1, 2, 3, 4, 5, and left 1. Again, as long as you have a straight edge and you're fairly neat, you do not need to count the rise over run more than once. Once should be enough. It only takes 2 total points to make a line, and that should be your y-intercept, then 1 more. Okay, number 6 doesn't at first glance maybe look like y equals mx plus b, but if we think about putting the m is 1 and our b is 0. So the y-intercept is 0, and my rise over run is 1. In fraction form, that's 1 over 1. So from the origin here, rise 1, run 1, dot. Rise 1, run 1, dot, 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 dot. We can see that just makes a line right through the origin, splitting our graph at 45-degree angles. Okay, and last one for the day. This one, again, it's kind of in disguise. It doesn't exactly look like y equals mx plus b, but if we want to think of it that way, it's like having y is equal to no x's, then minus 4. So your y-intercept is negative 4. We can put that on 1, 2, 3, 4. But our slope of 0, so if the slope is 0, and that's rise over run, that's 0 over 1, you would rise none and run 1, or rise none and run 1. So it turns out this is just the equation of a horizontal line, all right? Anytime you have y equal to just a number with no x in the equation at all, that is the equation of a horizontal line. That line has a slope of 0.